Okay, class, we're going to end the bone chapter by talking about a few pathologies of bone. Okay, we start first with osteomalacia and rickets. Osteomalacia is in adults, rickets is in kids. Rickets has to do with a vitamin D deficiency, but osteomalacia and rickets, the bones are soft, which means you have the organic matrix, which was the cells, fibers, and AGS, amorphous ground substance, but not enough inorganic matrix, which is the calcified matrix. So the bones, therefore, are soft. There's a deficiency of adequate inorganic calcified matrix. Calcium salt's not deposited. Rickets, which give bowed legs and so forth. Vitamin D deficiency is the cause of this, insufficient dietary calcium. It could be vitamin D deficiency or insufficient dietary calcium. Let's talk on vitamin D here. So let's digress for a moment. Okay, earlier we talked on parathyroid hormone. We said parathyroid hormone is released from the parathyroid gland as we spoke, and it increases the blood calcium level. Okay. Now, vitamin D makes calcium available. So here's what I'm going to show you. PTH activates vitamin D. Vitamin D's job primarily is it can increase bone breakdown, but really what it does more to do is increase reabsorption of calcium in the kidneys and absorption in the intestine. So vitamin D is very important for absorption of your calcium in the intestines. Now it doesn't do, I'm going to take this out, it does very little of this. It does very little of this right here. Take that out. So primarily what it does is increase reabsorption of calcium in the kidneys and to work here, increase in the intestine to make more calcium available. Vitamin D is very important in making calcium available. Okay. So we go here, osteomalacia, which is in the adult, is more common found in confined dark-skinned individuals, mainly because you can't get that sunlight through good. Okay. We'll go further then. Here's some causes of osteomalacia: insufficient sunlight, renal tubular acidosis, which is a problem in the kidney, malnutrition, and so forth. Soft bones. Now we're going to talk about density of bone. See, that was just soft bones. Here is what we call a bone scan. Ladies have it a lot. Because ladies break down, their bones are less dense generally. So this density scan, what it does is scan the density of the bone. Okay. Now, osteopenia is a condition where the bone mineral is lower than normal. It's considered by many to be a precursor of osteoporosis. Now, when we talk about penia and porosis, we're talking about both matrices. There's actually a decrease in both matrices. So in other words, instead of the bones being soft, they would look more like that pathology I mentioned here. See that low density right there? That low density? Okay. So we go back here. So osteopenia is a precursor to osteoporosis. Now I'm not going to get all into statistics, but here is the statistical bell-shaped curve that shows where a normal distribution. So we're saying that on the Z-score, which I'm not going to get in, a normal Z or higher. Osteopenia is less than a 1 on this bell-shaped curve. And then if we get to porosis, it's even further out. It's much lower. So on this side here. So osteoporosis, loss of bone mass. Bone reabsorption outpaces deposit. Okay. Lack of estrogen, particularly in females, calcium, vitamin D, so forth like that. And so these bones are very osteoporotic. See how that is right there? Easily to fracture. Treatment and prevention, calcium, vitamin D, weight bearing, piezoelectric effect. You see what I'm talking about? Hormone. And that's osteoporosis. So osteopenia precedes osteoporosis. And once you get to a certain amount of bone loss, then you're in porosis. Okay. I'm not going to get into all the drugs and everything, just showing you. Okay. Then we have what we call Paget's disease. It's a haphazard form of bone. What you do is take bone away and put it back, but it's very haphazard. It's not timed right. Pagetic bone has a very high ratio of spongy to compact bone and reduced mineralization. So you're putting it back wrong, shall we say. Okay. Bone tumors, osteoma is a benign bone tumor, and osteosarcoma is a malignant bone tumor. That's about all I'm going to say. Osteoma benign, osteosarcoma is that. We have multiple myeloma, which I'll talk about in ANP2. It has to do with within the bone marrow where you have B lymphocytes. I'll bring that up then. Chondrosarcoma is a tumor, is a cancer. See, a sarcoma is a cancer. That's a cancer of cartilage. Okay. Bone metastasis. Remember, with a tumor, you had a primary site, and then the cancer could metastasize. So a bone metastasis is when you have a secondary site. It's not a primary bone tumor like a osteosarcoma. It's secondary to some other tumor that is spread there. All right, I'm going to close here. These were just a little pathology to kind of give you an idea since we did the normal. And we'll now close.